Namaskar, I am Anand and you are watching Join for Education. Today I am going to answer the questions of work and energy. This is the 11th chapter of class 9. Let's see the first question of this chapter. A force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. What is the work done in this case? So this is the 7 Newton and displacement is the 8 meter. When a force F acts on an object to displace it through a distance s in its direction, then the work done W on the body by the force is given by. So work done equal to force into displacement. Work done is generally denoted by W, force is generally denoted by F, and displacement is generally denoted by S, and force is generally denoted by F. From question it is clear that F equal to 7 Newton and S equal to 8 Newton. Now putting the value of F and S here, therefore work done W equal to 7 into 8, and this one will be 56 Newton meter, and the SI unit of work is also joule, so we can write 56 joule 2. So this is the numerical solution of the question number 1. Hope that there is no problem to understand. Let's see question number 2. This is the question number 2. When do we say the work is done? Work is done whenever the given conditions are satisfied. A force acts on the body. There is a displacement of the body caused by the applied force along the direction of the applied force. So these are the two conditions through which we can say that work is done, otherwise not. So hope that there is no problem to understand the answer of the question number 2. Let's see question number 2 of this page. Write an expression for the work done when a force is acting on an object in the direction of its displacement. So the answer of this question will be when a force F displaces a body through a distance s in the direction of the applied force, then the work done W on the body is given by the expression work done equal to force into displacement. Force is generally denoted by F and displacement is generally denoted by S, and work done is generally denoted by W. So W equal to Fs. Let's see question number 3 of this page. Define 1 joule of work. The definition of 1 joule of work is in this way. 1 joule is the amount of work done by a force of 1 Newton on an object that displaces it through a distance of 1 meter in the direction of the applied force. So hope that there is no problem to understand the answer of the question. Define 1 joule of the work. So let's see question number 4 of this page. A pair of block exert a force of 140 Newton on a plough. The field being ploughed is 15 meter long. How much work is done in plugging the length of the field? So let's see answer of the question. This is a numerical problem. Work done by the blocks is given by the expression. We recall the definition. We recall the numerical explanation of the work done. Work done equal to force into displacement, or W equal to F into D or F into S. Here or where applied force 140 Newton, displacement D equal to 15 meter. Now putting the value of F and D here, then we get W or work done equal to 140 into 15 equal to 2100 joule. Hence, 2100 joule of work is done in plugging the length of the field. Hope that there is no problem to understand this numerical solution. If you have, then join to me in my YouTube live class every Sunday. This is the question number 1 of page number 152. What is the kinetic energy of an object? So kinetic energy is the energy possessed by a body by the virtue of its motion. Every moving object possesses kinetic energy. A body uses kinetic energy to do work. Kinetic energy of hammer is used in driving a nail into a log of wood. Kinetic energy of air is used to run windmills, etc. So, the ability to do the work of a body due to motion is said to be the kinetic energy, and it is generally denoted by capital alphabet Ke, and the numerical value of kinetic energy is 1 by 2 mv square. So hope that there is no problem to understand the answer of the question, what is the kinetic energy of an object. Let's see question number 2 of this page. Write an expression for the kinetic energy of an object. So the answer of this question will be, if a body mass m is moving with a velocity v, then its kinetic energy Ek is given by the expression kinetic energy half mv square. Its SI unit is joule. The SI unit of the energy is joule, or kinetic energy is joule. Let's see question number 3 of this page. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What will be the its kinetic energy when its velocity is doubled? What will be its kinetic energy when its velocity is increased 3 times? Let's see. Expression of the kinetic energy half mv square. M is the mass of the object, and v equal to velocity of the object in meter per second, or in SI system. Given that kinetic energy equal to 25 joule, for one first part of this question, if the velocity of an object is doubled, then it will be 10 meter per second. Therefore, the kinetic energy became 4 times its original value, because it is proportional to the square of the velocity. So, hence the kinetic energy equal to 25 into 4 equal to 100 joule. Hope that there is no problem to understand this section of question number 3. Let's see next part of this question's answer. If velocity is increased 3 times, then its kinetic energy becomes 9 times its original value, because it is proportional to the square of the velocity, and the kinetic energy equal to 25 into 9 equal to 225 joule. Let's see next question, or first question of exercise 156. What is power? So power is the rate of doing work, or the rate of transfer of energy. If W is the amount of work done in time t, then the power is given by the expression W by T, power equal to work by time, or work, the ability to do the work is known as the energy. So we can write down here energy by time. Power is generally denoted by P, and work done is generally denoted by W, and time is generally denoted by T. So P equal to W by T, it is expressed in watt, or the SI unit of the power is watt. Hope that there is no problem to understand the answer of this question. Let's see second question of this page. Define 1 watt of power. It is very easy to define 1 watt of power, which is here. A body is said to have power of 1 watt if it does the work at the rate of 1 joule in 1 second. So the example for 1 watt equal to 1 joule per second. Hope that there is no problem to understand definition or 1 watt of power. Let's see next question of this page. A lamp consumes 1000 joule of electrical energy in 10 seconds. What is its power? So power is given by the expression power equal to work done by time. So lamp energy is also a kind of work. So work done equal to energy consumed by the lamp equal to 1000, and power equal to 1000 by 10 equal to 100 joule per second, and this one is known as the watt. Of that there is no problem to understand the solution of this numerical problem. Let's see question number 4. Define average power. So the answer of this question will be a body can do different amount of work in different time intervals. Hence it is better to find average power. Average power is obtained by dividing the total amount of work done in the total time taken to do this work. Hope that there is no problem to understand this statement, which is answer of the question. Define a average power. So the average power equal to total work done by total time. Let's see next question or main problems of this chapter. Question number 1. Look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. Shuma is swimming in a pond. A donkey is carrying a load on its back. A windmill is lifting water from a well. A green plant is carrying out photosynthesis. An engine is pulling a train. Food grains are getting dried in the sun. A sailboat is moving due to wind energy. So let's see the answer of this question. Suma is swimming in a pond. Suma is doing work as she is able to move herself by applying force with the movement of her arms and legs in water. Hope that there is no problem to understand the answer of this question. So the answer of the second question of this part of the question is a donkey is carrying a load on his back. Donkey is not doing any work in the sense of physics as the weight he is carrying, the direction of force and displacement are perpendicular to each other. Hope that there is no problem to understand the answer of the second part of this question. Let's see answer of the third part of this question. A windmill is lifting water from a well. Windmill is lifting water from a well and doing work against the gravity. So hope that there is no problem to understand the answer of the question. Let's see next question or answer of the next question, which is here. So a green plant is carrying our photosynthesis. Hope that there is no problem to understand the explanation of this question. No force and displacement are present here, so work done is 0. So the work done is depend upon the force, applied force and displacement along the direction of the force. An engine is pulling a train. During the pulling, a train engine does the work against the friction present between the railway track and wheels. Of that there is no problem to understand the answer of this question. Food grains are getting dried in the sun. So the answer of the question will be in this way. During the dyeing the grains, there is no force as well as displacement is present. So no work is done. So in this process, displacement is present and there is no force. So the work done is the multiplication of force and displacement. Let's see next question. A sailboat is moving due to wind energy. Work is done by the wind as it moves the sailboat towards the direction of the force. Force is blowing air. Hope that there is no problem to understand the answer of this question. Let's see next question. Question number 2. An object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and the final points of the path of the object lie on the same horizontal line. What is the work done by the force of gravity on the object? So the answer of this question will be here. When the object moves upward, the work done by gravity is negative, as the direction of gravitational force is towards the earth's center. When when the object comes downward, there is a positive work done. So the total work done is 0 in throughout the motion. Hope that there is no problem to understand the answer of the question. Let's see next question. A battery lights a bulb. Describe the energy changes involved in this process. Battery convert chemical energy into electrical energy. The electrical energy further converted into light and heat energy. So there is the exact answer of the question 3. Hope that there is no problem to understand. Let's see question number 4. Certain force acting on a 220 kg mass changes its velocity and 5 meter per second to 2 meter per second. Calculate the work done by the force. So we know that from the question it is clear that mark of the mass of the body is 20, initial velocity 5 meter per second and final velocity 2 meter per second. Work done, change in kinetic energy equal to 1 by 2 mu square minus 1 by 2 mb square. So we take m as the common, whole star tu square minus b square. According to the question, the value of m is 20 Newton and the value of u is 5 meter square and value of v is 2 meter square. So the explanation of this one will be this one cancelled out and we get here 10 whole star 25 minus 4. So here 1210. Hope that there is no problem to understand the numerical solution of this numerical problem. Let's see next question of this chapter. This is the question number 5. A mass of 10 kg is at a point A on a table. It is moved towards B if the line joining A and B is horizontal. What is the work done on the object by the gravitational force? Explain your answer. So the work done by the gravitational force acting on the body is 0 because the direction of force is vertically downward and the displacement is horizontal. Force and displacement are perpendicular to each other. Hope that there is no problem to understand the answer of the question number 5. Let's see question number 6. The potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? So see the answer of this question. The potential energy of freely falling object decreases and its kinetic energy increases as its velocity increase progressively. So in this way, the total mechanical energy, kinetic energy plus potential energy remains constant. Thus, the law of conservation of energy is not violated. So this is the exact answer of the question number 6. Let's see answer of the question number 7. What are the various energy transformation that occur when you are riding a bicycle? Answer of the question number 7 is in this way. The muscular energy of the cyclist is converted into kinetic energy uh, and rotational energy, kinetic energy of the wheel and cycle, which is further converted into kinetic energy to run the bicycle. So this is the answer of the question number 7. On hope that there is no problem to understand the numerical solution of this chapter. Let's see question number 8. Does the transfer of energy take place when you push a hug rock with all your might and fall to move it? What is the energy you spend going? So the answer of the question will be in this way. When we push the rock and fail to move it, some of our energy is absorbed by the rock and in the form of potential energy, and the best of our potential energy is decreased and अच्छा दौड़ेगी और ये so the answer of the question number 8 will be this one, and hope that there is no problem to understand the solution of answer of this question. Let's see next question. Question number 9. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? So 1 unit equal to 1300 joule. So 250 units equal to 250 into 36123450, and after the calculation we get here 9 into 10 to the power 8. So it is very easy to join. So here has the energy consumed. Let's see question number 10. An object of mass 40 kg is raised to a height of 25 meter above the ground. What is its potential energy if the object is allowed to fall? Find the kinetic energy when it is halfway down. So the answer of this question will be, we know that potential energy equal to mgh, and here or where m equal to 40 kg, g equal to 9.8 and h equal to 5 meter. So the potential energy equal to 40 into 9.8 into 5. So this one will be 1960 joule. Let's see next problem or question of this exercise. According to law of conservation of energy, the potential mechanical energy, kinetic and potential energy of an object remains constant. Let's see. Therefore, when the object is half away down, it's proportional. Hence, the original energy and remaining half converted into kinetic energy. Hence, the kinetic energy equal to half m. The value of m is 1960 equal to 980 joule. Hope that there is no problem to understand to write the answer of the question number 10. Let's see next question. What is the work done by the force of gravity on a satellite moving around the earth? Justify your answer. So the answer of the question will be in this way. When a satellite moves around the earth, the displacement in short interval is along the tangential direction, and the force, gravitational force, is towards the center of the earth. Since the force and displacement are perpendicular to each other, the work done by gravitational force is zero. Hope that there is no problem to understand the answer of the question number 11. Let's see question number 12 and its answer. Can there be displacement of an object in the absence of force acting on it? Taking discuss the question with your friends and teachers. Let's see the answer of this question. Yes, it is true there may be displacement in the absence of force. We know that F equal to ma. In the absence of force, F equal to 0, then ma will be 0. If a equal to 0, the object is either at rest or in a state of uniform motion in a straight line. In case the object is moving in a straight line, there must be displacement. So the absence of three forces, there may be a displacement of power. Let's see question number 13. A person holds a bundle of hay over his head for 30 minutes and good girls tired has be done some work or not. Justify your answer. The power holding by hay get tried because each member energy is converting into thermal energy. There is no displacement at all, so that had no work, as work done equal to force into displacement. So the answer of the question number 13 is very easy and we have no problem to understand. Let's see question number 13. A person holds a bundle of hay over his head for 30 minutes and got tired. Has he done some work or not? So justify your answer. The person holding a bundle of hay get married because his muscular energy is converting into thermal energy. There is no displacement at all. So he had no work, as work done equal to force into displacement. Let's see question number 14. An electric heater is rated 1500 watt. How much energy does it use in hours? We know that energy equal to power into time. So power is 1500 and time is थोड़ा सा कम पड़ा. So this is the numerical problem and this is the solution of the numerical problem. Let's see next question. Time equal to 10 hours equal to 10 into 60 to 60 seconds, and the energy used for heater, power into time, normal energy, normal work. Now the value of power is 1500 and the value of time is 1600. किसी को कुछ से लेना, there is no to take from help of any statement of the answer. So the value of power is 1500 and time is 30,000 second. Altogether these are known as the joule. After the mathematical calculation we get this one, and when we convert this one into a standard form, then we have one and only one digit in the left hand side of the decimal. So this is the exact representation. 5.4 into 10 to the power minus 7. Let's see question number 15. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw uh, pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? When what happens to its energy? Eventually it is a violation, and it is a given pendulum. There are three cases of point to be discussed. Uh, this is the potential energy and this is the kinetic energy. When the bob is at rest, then the kinetic energy will be 0 and potential energy will be mgh. Here h is the height between here to the surface of the earth. Let's see next question. all the points B and C are pendulum. Bob is at its maximum height, so its potential energy is maximum and kinetic energy is zero. In this way, the total mechanical energy remains constant at the point A. The pendulum bob is at its lowest point. Total potential energy is converted into kinetic energy. Now the kinetic energy is maximum and the potential energy is zero. Once again, the total mechanical energy remains constant. So let's see. This is the question number 16 of this exercise. An object mass m is moving with a constant velocity v. How much work should be done on the object of other to bring the object to rest? Let's see, the object is in motion, so its energy equal to kinetic energy equal to 1 by 2 mv square. The kinetic energy of the object when it becomes to rest is 0. So work done an object equal to change in kinetic energy equal to 1 by mv square minus 0 and 1 by fv square. Let's see question number 17. Calculate the work required to be done to stop a car if 1500 kg moving at a velocity of 60 km per hour. So the answer or numerical solution of the question number 17. From question it is clear that mass of the car m and equal to 1500 kg car. Velocity of the air is 60,000 and here will be 663600 3600. So the exact answer will be 60 into 1000 and after the mathematical calculation we get here 5 by 3. There is an emotion, so energy, kinetic energy equal to 1 by 2 mv square and after the proper calculation we get this is the joule. The kinetic energy of work done an object when when it comes to rest 0 joule, change in kinetic energy 20,2023 equal to 0 joule and 208 333 and upgraded middle school is 220 and एक ही साथ T3353. So this is the answer of the question number 17 and this is a numerical problem. Let's see next question. So question number 18. In each of the following force F is acting on an object of mass m, the direction of displacement from west to east shown by the longer arrow. Observe diagram carefully and state whether the work done by the force is negative, positive or zero. So let's see. This is the first stage, second stage and third stage. In the first case, the force and displacement are perpendicular to each other, so the work done is zero. If in the second case, the force and displacement are in the same direction, so work done is positive. In the third case, the force and the displacement are in the opposite direction, so the work done is negative. Let's see next question. This is the next question. Sony says that the acceleration in the object could be zero even when several forces are acting on it. Do you agree with her? Why? So the answer of this question will be, if the resultant force acting on a body in different direction is zero, then the acceleration will be zero if worship or which is used during the worship is zero. We know that in the net force is zero. So this is the numerical to find out the solution of Muhammad Rafi. Let's see question number 20. Find the energy in kilowatt hour consumed in 10 hours by the 4 devices of power 500 watt each. So the number of etna in device is 4 and each device consumes 500, so 2000 watt. Therefore the energy consumed equal to power into time. So we put the value of power 200 and in our work done hour. So after the mathematical calculation we get 20 units. 1 unit equal to 1 kilowatt per hour. Let's see question number 21. A freely falling object eventually stops on reaching the ground. What happens to its kinetic energy? When a freely falling body eventually stops on reaching the ground, its kinetic energy gets converted into heat energy as the body and ground become warm due to collision. Sound energy and into potential energy due to change of shape or deformation. Let's see answer of the question number 22 or next question or half that. This is the this chapter has only 21 questions and all of the questions are from NCERT textbook. Hope that this answer question will be useful to the students who are studying in class 11. If you think that this is the useful to the students, then please do circulate of other students of class 9 who are studying in class 9 and this one will be the useful to such types of the students. Once again, I thanks to all of you to stay with me. Answer of the last question. Thank you very much.